Assalamualaikum warahmatullahi wabarakatuh. So, for today lecture, okay, this recorded version will cover three subtopic: chain rule, differentiation of trigonometric function, and also differentiation of logarithmic and exponential function. So, what is chain rule? Okay, chain rule it is known as the most powerful differentiation rules. This rule deals with composite function. So if y is equal to fu is a differentiable function of u and u is equal to gx is a differentiable function of x, then y is equal to fgx is differentiable of x, and dy dx is equal to dy over du times du over dx. Or equivalently, we can say that d over dx of fgx is equal to f prime gx times g prime x. Okay, when applying the chain rule, it is helpful to think of the composite function f times g as having two parts, as an inner part and outer part. Okay, so we can say that, okay, f, this is the, okay, sorry, this is the outer function, and this part is the, this is the inner function. Okay, for example, you need to find the dy dx for y equals to x square plus 1 to the power of 3. Okay, so let u is equal to x square plus 1. So we have y is equal to u to the power of 3. Okay, then if we use the chain rule, so dy over dx is equal to dy over du times du over dx. So you need to find the dy over du. You have to differentiate the u function, the function u parts. So we got 3, okay, 3u to the power of 2. Okay, this one is dy over du. Okay, and then for du over dx, we got 2, 2x. Okay, this one is du over dx, so we will get 2x. Okay, dy over du, okay, this one is dy over du is equal to 3u to the power of 2. Okay, so dy over du is 3u to the power of 2. So you just replace, okay, u with x squared plus 1, and then du over dx we got 2x. So this is the result of the differentiation process using the chain rule. Okay. Next is the general power rule. Okay, if y is equal to u x to the power of n, where u is a differentiable function of x and n is a rational number, so dy over dx is equal to n times u x to the power of n minus 1, okay, d times du over dx. Or equivalently, we can say that d over dx for u to the power of n is equal to n u to the power of n minus 1 times u prime. Okay. Okay. Let's assume this part. This is u prime. Okay. U prime. Okay. So, how to use the general power rule? Okay, fx is equal to 3x minus 2x squared to the power of 3. Okay, 3x minus 2x squared to the power of 3. So, we let that u is equal to 3x minus 2x squared. Okay, this inner part, we change it into u. Okay, so we know that fx is u to the power of 3. So if we want to use the general power rule, this is the formula n u n minus 1 u u prime. Okay, apa maksudnya kat sini? Bila awak jumpa function yang dekat dalam dalam apa kurungan dalam bracket macam ni, maksudnya awak kena differentiate luar and then you have to differentiate yang kat dalam juga. Okay, sebab tu bila kita differentiate yang luar saja, kalau u kita differentiatekan dia akan 3u to the power of 2. Okay, tetapi u tu sendiri kat dalam dia kita perlu differentiatekan sekali lagi. Jadi f prime x is equal to 3 times 3x minus 2x square to the power of 2. Okay, this part. Okay, this is the first part and then you have to differentiate the inner part. So d of times d over dx 3x minus 2x squared. So differentiate this part. So you get 3 minus 4x. So the answer will be 3 times 3x minus 2x squared to the power of 2 times 3 minus 4x. This is our answer. Okay. So the next example, we want to solve using the general power rule, but our question involve radicals. So find all the points of graph of fx, equals to the cube root of x squared minus 1 to the power of 2. Okay, for which f prime x is equal to 0 and those for f prime x does not exist. Maksudnya dia nak suruh awak cari bilakah hasil differentiation kita tu dapat nilainya sifar dan juga f prime x does not exist. So, bila jumpa soalan macam ni, macam yang kita dah discuss minggu lepas, kita tak semestinya directly terus ambil dan selesaikan. Mungkin ada soalan yang kita perlu lakukan pengubahsuaian terlebih dahulu. Permudahkan permudahkan soalan tu supaya jalan kerjanya juga jadi lebih mudah. Untuk kes ni kita tahu yang bila keadaan macam ni kita boleh tulis dalam bentuk seperti ini. Dia jadi x square minus 1 to the power of 2 over 3. Okay, and then we apply the general power rule. Okay, with u is equal to x square minus 1. Okay, the inner part will become the u. Okay, so we know that general power rule will equal n minus 1 and then u prime. Okay, so 2 over 3 x square minus 1 to the power of negative 1 over 3 2x. Okay, so bila dapat jawapan macam ni, apa yang kita perlu buat, kita susun aturkan semula lah. Okay, 2 darab dengan 2, x jadi 4x. Okay, become 4x. And then the bahagian bawah, 3. Okay, and this, the power is negative 1 over 3. So, kita tulis dalam di bahagian bawah lah. Bawa ke bawah supaya ia jadi positif. Okay, so the answer will be 4x over 3 cube root of x square minus 1. Okay, so soalan kata bilakah f prime x equal to 0. Okay, so f prime x equal to 0 when x equal to 0 and f prime x does not exist when x plus or minus 1. Okay, sebab bawah ni tak boleh far. So does not exist when we put the value of x equal to plus 1 or minus 1. Okay, that is the general power rule and chain rule. Okay, derivative of trigonometric function. Okay, this is the derivative of trigonometric function. Okay, d over dx sine x. We got cos x, d over dx cos x, negative sine x. D over dx tangent x, we got secant square x. D over dx cotangent x, we got negative cosecant square x. D over dx secant x equal to secant x tangent x. And then we got d over dx cosecant x equal to negative cosecant x cotangent x. Okay, ini kalau awak punya sebutan, okay, d over dx and it is x right here. Okay, but, okay, if okay, this something u, it becomes a function x plus 1, x squared plus 3. So this part we have to use trigonometric function and the chain rule. Okay. Apa maksudnya kat sini? Okay. When we encounter the question like this, so we have to use the trigonometric function and the chain rule. So d over dx sin u will be cos u prime. So maksudnya kita differentiate this part, kita dah tahu sin x akan dapat cos x. So kalau sin u akan dapat cos u. Tetapi u ni kita kena lihat apakah nilai u kita. So u tu kita perlu differentiate kan. Okay, and then cos u becomes negative sin u prime, tangent u secant square u prime, d over dx cotangent u becomes negative cosecant u prime, d over dx secant u becomes secant u tangent u prime, and then d over dx cosecant u becomes negative cosecant u cotangent u prime. So, bendanya sama sahaja. Okay, cuma dia okay, cuma ada tambahan okay, kita perlu differentiatekan the u part ni. Okay, contohnya kat sini. Okay, y is equal to sin 2x. Okay, kita tahu kalau sin x dapat cos x, tapi kalau sin 2x kat sini kita kena gunakan chain rule kita. So y prime becomes cos 2x, d over dx 2x. So d over dx 2x we got 2. So the answer will be 2 cos 2x. Okay, another example, differentiate cos x minus 1. Okay, kita tahu kalau cos x dapat negative sin. Okay, so negative sin x minus 1, d over dx x minus 1. So, x minus 1 dapat 1 right here. So, it becomes negative sin x minus 1. Okay. Another example, differentiate y cos 3x squared. So, we got negative sin 3x squared, d over dx 3x squared. So, 3x squared dapat 6x. So, dia akan jadi 6x kat sini. Okay, so 6x times negative sin 3x squared. So the final answer will be negative 6x sin 3x squared. Okay. Okay, derivatives of exponential and logarithmic function. So the inverse relationship between the natural logarithmic function and the exponential function can be summarized as below. So ln ex is equal to x and e to the power of ln x equal to x. So let's see. The derivative of natural exponential function. can let u be a differentiable function of x. So d over dx e x is equal to e, okay, exponential x, and then d over dx e to the power of u is equal to eu du dx. Maksudnya bila dia punya power dia tu bukan x, okay, tapi dia something x plus 1, x plus 5, etc. etc. So you have to differentiate the power itself. So let's see. To prove the property 1, use the fact that ln ex equal to x and differentiate each side of the equation. Okay, ln e to the power of x equal to x. Ni memang fakta yang kita dah tahu sebenarnya. So d over dx kita nak untuk proving kita differentiatekan kedua-dua side. So d over dx ln ex equal to d over dx x. So we got 1 over e to the power of x, d over dx ex equal to 1. Okay, so d over dx ex equal to ex. Bawa ke sini. Dapatlah seperti ini. Okay, so when we have to differentiate e, okay, exponential of 2x minus 1, so we use the e to the power of u du dx. So, okay, this one is our u. Okay, so our du dx will be, okay, our du dx equals to 2. Okay, so eu du dx is equal to 2e to the power of 2x minus 1. So next part is logarithmic properties. You need to remember these logarithmic properties. Okay, we know that ln 1 is equal to 0. Ln AB is equal to ln A plus ln B. Ln A to the power of n is equal to n ln A. Ln A over B is equal to ln A minus ln B. Okay. So ln ataupun log. Okay, log pun kita gunakan properties yang sama je bendanya. Okay, so the derivative of natural logarithmic function. So let u be a differentiable function of x. So d over dx ln x, we got 1 over x. So d over dx ln u will be 1 over u du dx. Or we can say that it will be u prime over u. Okay, so this is a few example, okay, to increase your understanding, okay, how to do the derivative of natural logarithmic function. So we have ln 2x, okay, u prime over u. So our u prime is 2, okay, because this is our u kita 2x. So u prime kita 2. So u prime over u is 2 over 2x. So we simplify, it become 1 over x. So d over dx ln x squared plus 1. So u prime over u, okay, our u prime is 2x and u is x squared plus 1. Okay, for number 3 and number 4, it is a special case where you need to identify which formula of differentiation you need to use to solve this kind of problem. Okay, so for number 3, you need to use the product rules that you already learned last week. So d over dx x ln x. It means that x times x. So we use the formula of product rules u dv plus v du. Okay, so x d over dx ln x. Okay, this is our u, this is our v. So plus ln x of times d over dx x. So x times 1 over x plus ln x 1. So the answer, okay, this one becomes 1 and then ln x times 1 is ln x. So the answer is 1 plus ln x. Okay. And then okay, number 4, d over dx ln x to the power of 3. Okay. It becomes a 3 ln. Okay, so number 3 we use the product rule, and number 4 you have to use the general power rule. Okay, so in your tutorial you will see some question you need to answer using the quotient rule too. Okay, so d over dx ln x to power of 3 becomes a 3 ln x square. D over dx ln x, so 3x, 3 ln x square over 1 over 3 ln x square times 1 over x. That is the answer. So basically, okay, walaupun dah sampai parts macam trigonometri, logarithmic, tapi bila nak menyelesaikan masalah tu, menyelesaikan soalan, segala hukum differentiation yang you already learn, okay, from 2.1 until 2.4 and 2.5, you need to apply, okay, kena gunakan untuk selesaikan satu-satu masalah. Tak semestinya bila logaritmik hanya hukum logaritmik je yang kita guna, tidak. Okey, maksudnya segala hukum ataupun segala formula untuk differentiation yang telah dipelajari, okay, mungkin akan diguna pakai untuk menyelesaikan masalah-masalah yang berkaitan. Okay, so itu adalah ini adalah part lecture. Untuk tutorial saya dah sediakan lebih kurang 15 soalan, okay, yang melibatkan chain rule, general power rule, exponential dan juga logarithmic. Okay, so based on the notes, you have to try to answer all the question in the tutorial 4, and then we will discuss in the next class. Okay, face-to-face class. I think it is easier to have a discussion face-to-face regarding this topic. Okay, so see you next week. Assalamualaikum.